All right, so let's talk about multiplying and dividing exponents. So now we're just having no variables, no xy for now, just regular numbers. So solve the following: 4 raised to the power 6 times 4 raised to the power 3. Okay, so 4 raised to the power 6 times 4 raised to the power 3. So since they have the same base, okay, and we're multiplying these two exponents, so we can simply add their powers, okay? Add their powers. All right, so that will be 4 to the power 6 plus minus 3. If we open that, that will be 4 to the power 6. If we open the bracket, that will be 6 minus 3. That is equal to 4 raised to the power 3. And what is 4 raised to the power 3? Our answer will be 64. All right, so remember that. So I'll just write this down here. So I okay. So when we have exponents, or when we are multiplying exponents with the same base, okay, when we're multiplying exponents with the same base, okay, we can add their powers. Okay, so it will look something like this. If you have a raised to the power m times a raised to the power n, so you can simply say this is equal to a raised to the power m plus n. So you just simply add the powers. Okay, and also if you're dividing, so let's try the next one. So we have 3 raised to the power 4 divided by 3 raised to the power 2. All right, 3 raised to the power 4 divided by 3 raised to the power 2. So since we're dividing now, we just subtract. We subtract the powers. That's going to be 3 raised to the power 4 minus 2. And what is 4 minus 2? That is 2. So that will be 3 raised to the power 2. And what is 3 raised to the power 2? 9. Or 3 squared is 9. All right, so try. So when we are dividing exponents with the same base, we subtract powers. Okay. Usually the one at the top minus the one at the bottom. All right. So if we want to explain this, I'll be like a raised to the power m divided by a raised to the power n is equal to a raised to the power m minus n. So we subtract the powers. So we'll go to the next question. Okay, so we have 6 raised to the power 2 times 6 raised to the power 3. So since we're multiplying, 2 times 6 raised to the power 3, that is equal to 6 raised to the power 2 plus 3, which is equal to 6 raised to the power 5. So you can decide to find, 6 raised to the power 5 is the same thing as 6. I'm just use 6 times 6 times 6 times 6 times 6, right? Yeah. So 6 raised to the power 5, that will be, if I calculate that, that should be, let me see, 6 raised to the power 5 should give us 7, 7, 7, 7, 6. All right, 6 raised to the power 5 is 7, 7, 7, 6. Okay, and then we have this one, 7 raised to the power 3 times 7 raised to the power minus 2. Now that will be 7 raised to the power 3. Let me just write it here. Times 7 raised to the power minus 2, which is equal to 7 raised to the power 3 plus minus 2. Then we open the bracket. That will be 7 raised to the power 3 minus 2. And that is 7 raised to the power 1. And anytime we have a number raised to the power 1, that is that number. So 7 raised to the power 1 is 7. So I can type here any number raised to the power 1. Sorry, there's a slight lag. But any number raised to the power of 1 is that number. So 7 raised to the power 1 is 7. So any number raised to the power 1 is that number. I'll say, explain like, okay, a raised to the power 1 is equal to a. Okay, so thank you. Let's go on. So here we have 10 raised to the power 6 divided by 10 raised to the power 2. So since we're dividing, we're going to subtract the exponents. 10 raised to the power, so 2, 6. Okay, that will be 10 raised to the power 6 minus 2. And that will be 10 raised to the power 4. Now what is 10 raised to the power 4? We can just count. We can just put 4 zeros. 1, 2, 3, 4, and that is 10,000. So 10 raised to the power 4 is 10,000. So for 10, okay, for tens, okay, the power would just tell us the number of zeros. So example, 10 raised to the power 1 is going to be 10. 10 raised to the power 2 is going to be 100. You're going to have two zeros. 10 raised to the power 3 is going to be 1,000. You're having 3 zeros, you can see. So it kind of, the power and the number of zeros are going to be the same. So let's say 10 raised to the power, let's say 6, would expect 6 zeros. So that'll be a million. So 1, 2, 3, 1, 2, 3. Okay, now this one, 3 square plus. Okay, so now we're not multiplying. So that adding of the exponent won't work. So we just do it directly. Right, so 3 square. So so we have 3 square plus 3 cubed. So this could be a trick question. So just know that since we're not multiplying or dividing, so there's no need to add or subtract the powers. You can just do it directly. 3 squared is 9 plus 3 cubed is 27. Okay, and 9 plus 27 should give me 36. All right, so let's try with different bases now, or like a mix. So I think the idea of the first one is kind of fine. Different bases now, or to just, all right, so we have, let's do the first one. We have 8 to the power 3 times 8 to the power minus 2 times 5 to the power 3. So for different bases, so we can just do them directly. Like, so we don't have to. Okay, so if the bases of the exponents are different, okay, then we can't add or subtract powers. Okay, so if we have something like, say, a raised to the power m times b raised to the power n, it's not going to give you, so you can't say a raised to the power m plus n b somewhere. It's not a b raised to the power, no, it's not going to work. All right, so let's come back here. So we have 8 raised to the power 3 times, so these ones are the same base, so we can add them. Okay, so we have this down. So this will be 8 raised to the power 3 plus minus 2 times 5 raised to the power 3. So this will be 8 raised to the power 3 minus 2 times, what's 5 raised to the power 3? That's 5 times 5 times 5, which is 125. Okay, so we have 8 raised to the power 1 times 125. So 8 raised to the power 1 is just still the same thing as 8. So we have 125 times 8, which should give us 1,000. That's 1,000. So our answer here is 1,000. If we move on to the next one, so we have 5 raised to the power 2 times 4 raised to the power 3. So 5 raised to the power 2 times 4 raised to the power 3. Okay, what's 5 raised to the power 2? That's 25 times 4 raised to the power 3. That is 64. Okay, and then what is 25 times 64? That will be 16,000. So a calculator might help when you're dealing with big numbers. So now we have this one, 10 raised to the power minus 4. I'm sorry. 10 raised to the power minus 4 times 7 times. Now, since, so whenever you have, so I'll write it here. So whenever you have a whole number raised to a negative exponent. Okay, so whenever you have a whole number raised to a negative exponent, to turn it back to a positive exponent, okay, you, okay, so it becomes 1 over the number, let's see, the number raised to the positive exponent. What do I mean? So I say if we have a raised to the power minus m, that is equal to 1 over a raised to the power m. So it's like an inverse. Okay, so 10 raised to the power minus 4 will be 1 over 10 raised to the power minus 4, 10 raised to the power 4, sorry. Okay, that's the difference. That's just it. Okay, 10 raised to the power minus 2 will be 1 over 10 raised to the power 2. Okay, so we can do the same thing here. So we have 10 raised to the power minus 4 times 7 raised to the power 2 times 4 raised to the power 3. So 10 raised to the power minus 4 will be 1 over 10 raised to the power 4 times 7 raised to the power 2, which is just say 49, times 4 raised to the power 3, which is going to be 64. So this is going to be 1 over 10 raised to the power 4. How many zeros are we going to put? 4 zeros. 1, 2, 3, 4. This is 10,000 times 49 times 64. Okay, so it's going to be 49 times 64 over 10,000. Okay, so we can just use a calculator to calculate that. 49 times 64 over 10,000. That will be 0.3136. Okay, so this is just I just tried to put this question just to show how to deal with negative exponents, negative powers. So in the next videos, I'm going to show you more about power of products, quotients, different variables now multiplying with variables and all. So thank you and bye bye.